Okay, so this is our milling demo for assignment number 3. It's the 3x3 block. You guys can stand anywhere you like, but pretty much what you're going to need for this job is you're going to need a hammer. You're going to need 2 parallels. Shorter ones are better, about 3/4 of an inch to 1 inch. You're going to need the machinist square. Going to need a caliper. Going to need a file. Before you even get your tools, you got to go and cut your part. All right, so you should have viewed the bandsaw, printed off this assignment, and looked at the safety modules already. So everybody should be at that point. And now if we're ready to start, you have to remember when you take it off the saw, you're going to cut it a little oversized, like a 1/16 of an inch or so. And then whenever you pull a part off the saw, you're always going to have a burr on the edges. So you want to get yourself a file and make sure there's no burr protruding up onto the faces that you're going to be machining. In this case, we're going to square this entire block, all right, all 6 faces. So you should have a nice file. Some of them we have aren't so nice, but all I do is just run the edge, and then you feel all around it that nothing is sticking out. Be careful, don't be sliding your finger. It's kind of sharp sometimes. So once you have that cleaned up, what we're going to do is, and you also should have been able to check the tram and organize the alignment of the vise. If you haven't done that already, you should do it. So what we're going to do is we're going to go about and, let me see, I might need slightly longer parallel block. Yeah, I think I'll get a longer pair. These are only about 3/4. I think 1 inch would be better. They're about 7/8. So hang on, let me get a couple parallels. And where's your glasses? The parallels are inside the wooden cabinet, off in the back of the shop. We're the same place you find the calipers. Okay, so what we're going to do now is simply take this part. What we're going to do is machine all 6 sides, the 2 large ones, these 2 and these 2. And what we're going to do, if you print out this drawing, the finished size has to be 2.938 length, 2.938 width, and 0.938 thickness. So this is a piece of stock. It's 1 inch by 3 inches, and you're going to cut it by 3 inches, slightly oversized. So what we have to do is, number 1, machine all the faces square. Although the mill these days produce pretty good squared parts. These are extruded aluminum parts. You'll still find they're out of square. The saw is very good, but it also cuts things out of square a little bit, so you want to be checking the squareness. And what we're going to do is make sure this entire part is square, so that when you put it up and check for perpendicularity, you are going to verify that there's no light coming through. So, because you know, if you were sort of out of square, you'd see something like this, right? So as you hold it and look, you'll see there's little gaps here and there, but it's pretty true from the factory through the extrusion process. But what we still want to do is we have to take it down the thickness, right? And we have to do it so that we can maintain a very close squareness tolerance going this way and this way. So here's we have our parallels in, they're pushed up against the back. These are 1 1/8 inch parallels. And then what you're going to do is just kind of snug a piece in. You can take your hammer, pound it down, make sure, just give her a couple taps, make sure it's sitting nice and flat. And then you can get this vise handle out of the way until the next step. Now what you're going to do is you're going to come over here. You'll see a table between each of the 2 milling machines. These are tools for both machines that's in the middle of. And your basic tool for doing this is a 3-pointed fly cutter. This is a surface or a face mill as they call it. It has 3 points on it. And it is going to be coming across the top of our part there to make it to thickness. Now, you remember from the last time when we went tramming, we said we have a nice taper here. This is called an R8 holder. And just to remind you how it works, there's a keyway here, and inside the spindle you'll find a little keyway. So the first step is that you'll reach behind here and you'll find a little wrench. This one has a little bit of brass brazed onto it so we can use it as a tapping hammer. But first thing we're going to do is put the holder in the spindle and gently rotate it until you find that keyway. Okay. Sometimes it needs a little help, but you'll feel it pushing up your drawbar, and we talked about the drawbar. So what you're going to do is twist this thing on as hard as you can, as much as you can by hand, and you'll see the tool is now mounted in there. Off on the side here, it's easier if you put it in a low gear. So now it won't rotate very easily. You can also apply the brake up here, put your handle on and torque it down. Don't clamp the heck out of it, you just got to make it snug. So now we've got our tool nicely snugged up against the, these wrenches always stay behind here. They never go away, and make gosh darn sure you don't keep it up there, all right? Number one, huge. You see these marks here, we got lucky and somebody left them in and bashed up our housing, but luckily nothing broke. On another one, somebody left it in, twisted it, this whole drawbar snapped. You know, these are avoidable problems, so just remember, always, 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 never leave that up there. So right now we are ready to start machining. And I'm going to put the hammer off on the side here for now. And the way we do this is we're going to use our table adjustments. We're going to have this end mill is approximately 2.5, 3 inches in diameter. And what we're going to do is now we're going to take and do what's called a cleanup cut on our first surface. It also helps if you have a little Sharpie. So let me get one real quick so that you can do this to remember. Because it's a very important order. We got some safety glasses over there you can use. I think they're in the drawer there. But this is, you want to get out there. All right, so those of you watching this on video, we're just running around the shop talking. I've got signal, everything is working. Everything's working today. For a Monday, that's a good thing. Now, you've probably known we had some troubles with Blackboard and all that. That's a whole other story. But anyway, we're ready to start machining. You remember you had controls going this way. You want to make sure these locks right here are loose so that the axes move, X, Y, and Z. And what you want to do here is this one, we want to take and bring this knob all the way up to the top so that our spindle rests on that, and then we're going to lock it down. When we're doing milling, these are milling operations. These are not hole drilling. We want this spindle tool to be up in the spindle. We don't want it sticking way down because that'll give an opportunity for it to deflect and move a little bit. So we want to do our machining when we're doing end milling with this spindle, because remember it can go up and down when we do drilling, but it has to be way up top. So if you remember how to do the speeds, you have to make sure that you are in a high gear for this operation. And what you can do is you can sort of jiggle this knob and make sure you click, because if you don't, it's going to make a horrendous noise of teeth grinding if it's not fully engaged. You'll know it's engaged because it'll just kind of snap in there. Here's our speed indicator, the turtle and the rabbit. When we're in high gear, the rabbit is active. So it's going to be at about 200 RPM now, okay? So what we do is if you're in high range, your knob here goes to high range. And the first thing you have to look at is, number one, notice there's no guarding around here, so obviously you're going to keep your hands clear of all this, right? Number two, that it's rotating clockwise toward you, like that. Every tool we use will always be a clockwise motion. As if you're looking down the end of the spindle, it's going clockwise, okay? Hugely important. And now what we're going to do is we're going to position this thing into shape. Now what we're going to do is we're going to adjust the knee here. And we're going to get ready to do our first cut, and this first cut is what we call a cleanup. So we're just going to cut it. You can come over here, guys, too, if you want. You don't have to stand all the way back. And you're going to kind of eyeball. I'm going to turn this spindle off right now so I can kind of show you what I'm doing here. I'm going to turn that off. Now the spindle has a diameter, or the tool rather has a diameter, right? So what you can do with this tool, because we're machining across a surface, you can approximate, just make sure that your tool covers the whole surface. So when we start machining, I'm going to be doing this, and you want to make sure your tooth is just past the face there. And then we're going to move this way, and we want to make sure we're going to overlap. Okay? So you should overlap about 75% of your cutter. So what we're going to do is just kind of be safe right here. And we're going to start our machining. You'll notice I'm still up in the air here. But what I'm now doing is taking the cutter so that it's just a little bit off the edge, but it's still over the top of the part. This is kind of like the lathe. So those of you that did the lathe work, you know we do a little touch off, right? And then we drag our tool off of it, bring it in, and then start machining. So I'm going to do here, I'm going to turn on my cutter. You never want to turn on your cutter if, one thing we want to be is we want to be disengaged here. So right here, disengaged on that wheel. You'll see if this thing is turning, that means you're engaged. And we're going to use this later on in the class, but right now you don't want it. See, now it stopped rotating. So what we're going to do is now we're going to use the knee here. And we're going to do a very light, slow, bring the tool up to the, or bring the material up to the tool. And I'm set at about 1200 RPM. Okay? That's sort of ideal for this cutter. So what we're going to do is we're going to slowly touch off. You see that? It just barely touched it. You'll hear it, you'll see it. You've got a little shiny ring right there. And what we're going to do is like kind of gently move that off. And now what I'm going to do is I'm going to just move this thing about 5 thousandths up. Now we're going to do our first cut. What you want to do, and these things are hot by the way, so you'll see they come flying at you. Stand somewhere where they're not. And you're going to bring this through nice and steady, nice and easy. And we're going to make a cut. You want to make sure, if you all look right now, I'm going to turn this off again. You can see where I've just cut, and you can see the original finish still. The depth of cut, in other words, how much I took off here, is like 5 or 10 thousandths. With this cutter, you don't want to go more than 20 thousandths at first. Even though this is aluminum, these are not designed for real deep cuts. So you have to keep it real light. And you can see right away where we've already cut. Then you're just going to advance this up. Again, keeping your face out of the tool. Make sure you got a little overlap, and now you're just going to come back. Okay? We're kind of feeding fast. And you'll see that the faster you go, the rougher it is. But I'm not too concerned about finish at this point. I'm concerned more about having you be able to do this and come out with a part that's square. Now if your head is really nice and trammed, what you should see, if it's correctly trimmed, you should see marks that go this way and that way that kind of overlap each other. That means the cutter's running flat. There should be no real noticeable ridge here between the two cuts. That means it's trimmed that way, okay? So this is a little rough right now, but it's showing two kinds of tracking. Sort of semicircle going this way, semicircle going that way. I'm going to have you, when you're first coming up to these, generally what I like to do, I like to take a square, hold it against the quill, make sure it's not real obvious out of tram. Just check it. You don't have to indicate it every time, but just check it with a square. So now that we've taken our first cut, what we're going to do is bring the table over here, and we've cleaned up. We've cleaned up this surface entirely. That's exactly what we want to do. And I don't really want to move this right now, but what we're going to do is open up the vise, and this is our first surface. So I'm going to put the number 1 on this surface. That's the first surface we cut. It's very important. When you look at the vise, this is the jaw that moves back and forth. This is the solid jaw. You always want to have referenced work. So if you've got reference edges and such against the solid jaw, this is always going to hit you that way or that way. But this solid jaw is fixed. So our next step is going to be to machine. This is surface 1. What we're going to do is we're going to square off another face here, this one. We're going to go for cleanup on this one face here. So what we do is just pull the parallels out for this part of it. And now these blocks come out of the mill, like I said, extruded. They're pretty square. So what we can do is we can simply lay it flat. Again, you have to make sure there's no chips in here, okay? Because if there's chips, that means the part will be like this. And then what's going to happen? You won't be square. The chips mess you up. So keeping these surfaces clean and free of chips flying around. Now notice, number 1 surface pushed up against the back of the vise, the solid jaw. Okay, really important. And it's just sitting on the guides here. This is a precision vise, so you don't want to be pounding on it or in it. It is simply for holding your work. And then because these backs are movable, these sometimes might move up and down a little bit, so you snug it. If you hand me the orange hammer, please. You want to take it and then give it another tap. Make sure you're good and firm on the bottom. And now we're going to do a cleanup on this edge, the number 2 edge, okay? So this one, we only need to go 1 time across. So you can make it so it kind of goes and meets the cutter right down the middle. But look at this, we're way too deep, see? We can't use it that way, of course, because our maximum depth of cut is just going to be a little bit. So what we're going to do is kind of drop this down. And we're going to do the same thing. We're going to touch off, and we're going to make sure we're not hitting. So there. And you'll see that I've just moved it up a little bit. Make sure everything is locked, vise, everything good. Okay, so now what we're going to do is make sure we're not hitting material. We're going to turn it on and slowly advance it until we get that first little chip again. Little bit at a time. You don't want to plunge this cutter real fast into material. We'll wreck it. Okay, so there's the edge. I'm now going to move about 0.10 of an inch. Set the dial to 0. Remember, every line on this dial is what? How far apart is it in actual movement? Remember? 1/1000 of an inch. Okay? So I just moved it 0.10 down, and we're going to go and clean up now. And I'm going to feed it a little slower, so hopefully we can get a slightly better finish. But you hear it cutting. These chips are flying. Obviously, we have safety glasses on, so they do get hot and sometimes get down your shirt, which is a little uncomfortable, but you can see now me having slowed down my feed, we are getting a better finish. And we don't need to do anything else, just a cleanup cut. In other words, get the entire factory edge off of there. Notice my hands are staying clear whenever that cutter's running. So here you see factory edge, and here you see my finished machined edge, and you'll see that it's very nice finish on there. I just slowed down the feed rate. We have a speed of 1200, and then the feed rate that's slow and easy. I know, Robert, you did really well on the lathe, keeping that feed rate nice and slow. You got a really super nice finish on it. There's a relationship between how fast that spindle's turning and how fast you're moving. The relationship is sort of by roughing, by sort of rule of thumb, the faster your head is turning and the slower you're feeding, the better your finish, okay? Because you're dragging more cutter in across the same space. We'll talk about that a little later. But just for now, realize that for this job, 1200 is the RPM you're going to use. At some point, we're going to figure out how to calculate the proper feed rate, or spindle speed and feed rate, actually. So now that we've done a nice cleanup on this side, what we want to do again is grab our file over there, if you would, please. Because now we've gone and machined and we've pushed up some burrs. So those will be our enemy. So always remember to knock your burrs off your surfaces, your corners. Whenever you've dragged the cutter across a surface, you're going to be pushing up burrs. And if these burrs get in between your vise jaws and the part, again, you'll have problems. Now what we should be able to see right off the bat is, this is my surface number 1, that's my number 2 surface. If I put my machinist tool handle nice and square on there, my machinist square, and push down and look up, there should be absolutely no daylight coming through this at all. And if you hold it up to a light fixture, you'll see that there's like no daylight. And it should be in that way as you run it across this way. Okay? So that's what our first perpendicular means, 90 degrees from here to here. Very important. Now, I'm going to put a little marker on that. We can put that over there, please. I'm going to put a little mark on there again. That was surface number 2. So we don't need to touch that one again. And whether this piece is, 5 by 4, you're always going to do one surface to second surface. Now what we do, keeping number 1 against the jaw back here, making sure that it's clean, we're going to put surface number 2 on top of the vise guides here, surface number 1 against the back, and we're going to take this thing to size. Okay? So our finished size will be 2.938. So if I can have the hammer and I give this thing a nice tap into the vise, just to make sure we're sitting down on there. And now what we're going to do is we're going to take a cut. I have not moved my handle yet. It's sitting at 0 right here on the dial. I'm going to turn it on, and we'll probably see that it's not going to touch, or very little might come off when we go in this direction. So you see there's barely anything going off of there. Barely anything. Why? Because we left it at the same surface. That shows just that the edge is not quite parallel. You'll see that only a little edge of it has cleaned up, and then the rest of this has fallen off. So what I'm going to do is, the maximum depth that we're cutting here is what? What's your maximum depth? I said it earlier. 0.02. Let's keep the 02 or 025. All right? 0.2025. So what I'm going to do is I'm going to now advance my wheel 25 thousandths. So here's 10, 25. And now it's just lifted it up 25 thousandths. And I can go this way. I'm going a little faster because we've got to do a couple of cuts before we get to size. So I don't want to plow it through there super fast, but I'm really not too worried about it going kind of slow. So I'm going to do another 0.25 because I happen to know that this thing, well, we should be safe and measure it. So now, you don't want to take it out of the vise if you can help it. What we want is a finish of 2.938. And so we remember we talked about how to use the back of this caliper to measure. We just kind of set this up to a length that's longer and just gently push this down onto the surface, and it will read 2.980. Okay, and we want 2.938. So that means we have about 42 thousandths, 0.042, to take off to get this to the finished size. So I'm going to do that right now. I'm going to do 25 thousandths. There's going to be 5, 10, 15, 20, 25. So I've just gone up 25 thousandths more. Turn it on, and let's make another cut. Again, we're not worried about finish on this cut, so what we're going to do is just get it through, not too fast, not too slow, don't drag it because we don't really need to worry about a finish at this point. Now, let's see what we have on our measurement. Got it there, got it there. I'm going to push it down just until it comes to a rest. 2.958. So that means we got to do another 20 thousandths, 0.02, right? To get it to 938. So here's my wheel. I'm sitting at actually 0.5. So I'm going to go 10, 20 thousandths more. And that should bring it home just to the right place. And now we're going to worry about the finish because this is our finish pass, right? So we're going to get it close. And we're going to now just turn it nice and easy. And slow. Important thing, the number 1 surface pointing back, the number 2 surface down. You've tapped it in place, you've deburred everything. If the machine is square, these 3 edges should now be perpendicular to each other. We'll just take a measurement before we take it out. It's good to leave your parts in the work holding if possible. Taking them in and out introduces a chance for possible errors. So here we go. Let's take a look at where we're at. Take it and just push it down again. Okay, I took a little more off. 2.935. 0.935. I'm 3 thousandths too far down. Why do you suppose? I moved 20 exactly. Well, there's physics at work. The part's heating up. I'm pushing it kind of hard, and didn't really spend a great deal of time using a really good, double, triple measurement. Usually I'll sit there and I'll do it 2 or 3 times, but I was just taking it for granted on the first one, because this you got to get a little feel for using this bit here, and sometimes it's not appropriate to use this. Sometimes it's better to use what's called the depth micrometer. But let's pop this out of there. Deburr it. Will you just knock the burrs off of that, please? Just watch the edge and just kind of run that across to get rid of the burr. And then we'll take a measurement. I'll clean this vise up while we're waiting to just clean it up. Now we're going to do side 4. We just did side 3. So we have, again, cleaning the vise, every little chip out of it. And okay, how's that? Can you see that? Feel that? Go this way. You feel it pushing up?
Oh,
yeah. Yeah, see, we got huge burrs just as you run your finger this way. Okay, that's what comes when you sort of, and then there's a burr here. So you got that one good, but we got to hit all of them, all the edges. And always, always, always. Sometimes the burrs are big and you got to work them a little bit. So now it's gone. Now this one we'll clean up just a tad more. We'll clean up this one. And we'll clean up this one. Okay, so notice the difference now. Just run your finger up and down there just to see for yourself on those edges.
Right.
No burrs is a good thing, right? So you did this, yes. Now it's just
do it a little bit harder.
yeah, a few more minutes and just feel it, and then you can kind of use that one's kind of a coarse one, but if you use it kind of at an angle like that and just kind of work it. We're not putting a chamfer on this, we're just breaking the burr, so it's going to have a little edge. But now we'll clean the part. So that was side 1. I've now got side 2. We've just done side number 3 here. And now it's going to get a little bit unusual, because what we need to do now is we need to do these 2 edges. Now these 2 edges were saw cut, so they can potentially be all over the place. Right? This is our saw cut edge. I did that last. Well, we still got to do that. This is the last surface, but the saw cut thickness is one that we have to do a little differently. So our parallels are out, and with the part really clean, surface number 1 against the back. But what we're going to do now is we're going to kind of lift this up off the bottom, tip it over a little sideways like this, sort of on purpose, and here's why. What we're going to do is we got to send that thing so that it's square up against our machinist vise. Now if you look through here, everybody should come and have a look at this. If you look through here, you'll see a big gap between the part and the square. Okay? So take a look through there and you'll see it. There's a big part. The part is sitting crooked like that. Now what we need to do is we need to get that face. I got the wrong surface. Look at me. I'm sorry. It should be sitting like so with side 2 over here. Let's just had the wrong side. Same theory will apply. So surface 2 is facing me. Surface 1 is to the back. And we have one of our saw cut edges here that we're going to machine. So what we want to do now, this is snugged in here. We've got the big gap right there. Surface 2 facing me up against the machinist square. What we're going to do is, we don't want to tighten it again afterwards. We're going to just kind of tap this thing until you feel it clip up against. Now it's up against the square and there's no light showing through. Okay? That means we are perpendicular. This face here, number 2 face, is exactly perpendicular to that surface. We just tapped it in place. Now we're going to do a cleanup on that surface. And I also don't encourage keeping tools on the machine surfaces. So if we've got tools, I got a little rubber pad under here. But I generally keep my precision tools here, not wrenches and stuff like that. But you should have a little protector, a little rubber, or we've got little foam things kicking around here that are basically drawer protectors. Now you'll also see, this is up in the air too, but it's actually square, that we're no longer in the right position to do a cleanup on this face. Okay? So we're going to take the table and we're going to drop it down just like we did before. We're going to maneuver that in there close. Now you see I'm up in the air a little bit, right? And when I spin this, I'm not hitting any material. So we'll leave that there. We'll turn on our piece clockwise, and now we're just going to gently do a touch. Not much on this cut. This is the number 4 cut, and it's just going to be to do a cleanup on this face. So what I tend to do is I just tend to tap this real gently until it touches. We got a little room to go still. It's just about ready to touch, I think. There it is. You hear it? You see it? I'm going to pull off. And I'm just going to take and move in about another 5 thousandths. 1, 2, 3, 4, 5. And we're going to do a cleanup cut on this surface. Feed it nice and slow. Nice and easy, just to get a good cleanup. 5, 10 thousandths, as long as you're touching the whole face. And you see we're not really. Okay, if you take a look at that, see how it looks. You'll still see the saw cut lines. Here's the saw cut, and there's where it actually touched. So it did not make a nice cleanup on that face. So let's just take it another 10 thousandths, and we should be there with a 10 thousandths cut. You know, we have 938 to 3 inches and 3 inches plus on this. You have quite a bit of room to just sort of get a good cleanup. But you don't want to gouge it in there. And we're still not cleaned up, so let me go a little deeper until I get that depth. And now we've got to clean up on the whole face. After a while, you'll see that you can use coolant on these things, but these cuts are so light, we don't really need any kind of coolant or anything like that. Now that's where we took a little more material, and we're just coming off the edge now, and we've got to clean up. That's all we need to do here. Did you take one in the t-shirt? See, now we've got a good cleanup, and we're done with that face, so we get it out of the vise, and we're almost finished. And then here's the important thing. We deburr it, and now we'll check for perpendicularity across all faces that we've machined so far. And if I did this right and to the proper procedures, you should be right in, nice and square. Always check your work in process. You don't want to put 2 hours into this and realize that surface number 2 was done on an angle. So keep yourself, always checking as you go. A lot of times you make a mistake, you can correct it before you finish the part, which then might say you can't correct it. But here's what we do. You've got perpendicularity from surface 1 to 2. We've got perpendicularity from surface 1 to 3. And now, surface 3 to 4, which we just cut, it's got a little bit of a gap, but not bad. Surface 2 to there, it's got a kind of a big gap. Take a look. And that was because we are sitting at a rough surface, and that's within 5 thousandths, so that's okay. But I have a feeling that this might have moved a little while I was machining it, and that's why it kind of pushed it there. It's still good. It's still good. And the good news is now we're going to put a number on this face, number 4. And now we're going to do face 5, which is cutting this surface to thickness with 4. Cleaning the vise. Number 1 to the back, 4 on down. Put that in there. Now, the biggest thing that goes wrong during this process is that you might have chips in the bottom, and even the slightest chip or the slightest burr, that piece will be out of round or out of square. Give it a tap. Always remember to give it a little tap down. And when you do that, you don't want to tighten again. Okay? So you tap it down. Now we'll do this, and then we'll take it to finish size. So I haven't moved this. I'm just going to set it to take about 5 thousandths. So I'm going to go 5 thousandths shy and then go right to 0 so that we can cut and measure. And then we've got a 0 reference surface. And then we can adjust and take our depth as needed. 20 thousandths max cut on this. Geez, I forgot. We had that up in the air, so the last thing we do here is touch off. Jumped one step ahead of myself. I forgot to do the touch off. Now I'm going to take it in about 10 thou, put it on 0. There we go. Here we are. Let's make sure we clean up on this surface. Looks good. If you take a look while I'm cutting, you can actually see it. And I'm just a little off, not quite finishing the cleanup. So you see I've got the machine surface here, and I've got the saw cut surface there. So let me take it down to another 10 or 15 thousandths, and let's see if that doesn't clean it up. Looks like we've got just a little hair up in the corner there. We've got plenty of room to remove, so I'm going to do another 5 thousandths. Set it back to 0. And then come back, and if it's clean, it's clean. If it's not, we'll be all right. I'll just do this one nice and quick. So Jacob, you want to grab that? Got one right in the nose. Grab that caliper and give me a height measurement after I turn the spindle off. And get these chips out of here. So give me a height measurement from the base of the vise to the top surface. Either side, it might be easier here because then the machine won't be in your way. So yeah, hold nice and square up against there. Yeah, that's a good way too. And now kind of just feel it a little bit. And we've got we got a long way to go. 3.135. 135. So we got over 1/8 of an inch to cut. But I think you guys get the idea that now we're just going to take it in a series of 20/1000ths of an inch, cut, measure, adjust, cut, measure, adjust. Or if you know, like right now, 135/1000ths, that means I'm on 0. That means we got to do a series of 20/1000ths to a full turn, and then another 35. So when it's done, this will have gone 1 revolution and then an additional 35. All right, I suggest you cut and measure, cut and measure. Then you'll see that you're hitting that 20/1000ths, or you'll get a reading of the deflection. So that's where we're at. And then what you would do is put your parallels back in and then take that face to thickness, which is 0.938. But I don't think I need to take you guys through the whole process. You can finish, somebody can finish that one, and you can go and start your own now. All right? Okay, so if somebody wants to step up and finish that one, go right ahead. You get to clean up the machine though. If you want to do it, and then you can keep the part for your assignment. So what I'm going to do is turn off our recorder now, and then we're done. It's a wrap. You want to do it? All right.